Assalamualaikum. Today we are going to continue our lesson with chapter 3, which is static and dynamic characteristic of instrument. In this topic there are two parts, which is static and dynamic, and which is involving in the theory and the calculation parts. Okay, now we take a look on the static characteristic of instrument. So, what is static characteristic? Static characteristic is the characteristic of instrument which do not change with time, So, there are 6 terminologies that we are going to cover in the static characteristic, which is first is error, second accuracy and precision, sensitivity, reproducibility, drift, and dead zone. Okay, first static characteristic is error. Okay, so as we all know, when we are doing a measurement, we can't have a perfect accuracy and precision because of what? Due to some error. Maybe error from the human, maybe error from the equipment itself. So, what does it mean with error? Error is the actual difference between the true value and the indicated value, which is given by this equation. Error is equal to VI minus VA, which is your VI is your indicated value and the VA is the actual value. So, error, we can classify into 3, which is we have systematic or cumulative error. You can have more reading on the textbook, page 35. And then we have accidental or random error. And the third one, we have miscellaneous type of gross error. We will discuss more about these 3 error in the next slide. Alright, for the systematic or cumulative error, it have the same magnitude and sign for a given set of condition, which is instrument bias. For example, first is the instrument error. Because of what? Because of the poor design or instrumentation. And then loading error by act of measurement on the physical system being tested. The next one is environmental error, which is due to the condition in the area surrounding the instrument. Okay, in terms of humidity, temperature, pressure, forces, and others. Okay, next is accidental or random error. This is due to the lack of consistency in the measured values when the same input is imposed repeatedly in the instrument. Okay, for example, we use ruler to measure an object. And every time you measure the object by using the ruler, you get a different data recorded over time. That is what we call accidental or random error. Or like another example is like in your previous dynamic experiment in the flywheel. If you still remember that we recorded time, right? We take 5 times of reading, and you can't get the same reading every time you measured or you take the time. Next is miscellaneous type of gross error. It's either systematic or random error. For example, human error, which means how you observe and you read the data to record. Next is faulty component or adjustment. And then the third one is the improper application of the instrument. This is the example of miscellaneous type of gross error. Okay, next static characteristic is accuracy and precision. Okay, so what is accuracy? Accuracy is how closely the reading of the instrument approach the true value. Okay, so accuracy of a measuring instrument is expressed by the percentage of the true value of the measured quantity, which is given by this equation as you can see on the slide. And what about the precision. Precision is the ability of the instrument to reproduce a certain set of reading within a given accuracy. Alright, you need to bear in mind that accuracy and the precision is a two different element. Okay. Now take a look on the accuracy versus precision. The first picture, the A picture, we have high precision with poor accuracy. We can see that on the target plate, the dot is near to each other, but it is not accurate because it does not hit the bull's eye. The second picture, which is B, it have a good average accuracy with poor precision. Okay, means the dot is near to the bull's eye but is not staying together or not near to each other. The third one is the high accuracy with high precision, means you hit the bull's eye and it precise, mean the dot is near to each other. You hit the target. Okay, the last one is poor accuracy with poor precision. We can see that the dot on the target plate is scattered to each other and it is far from the bull's eye. Okay, so in easy words, the difference between accuracy and the precision is accuracy is how closely your value to the actual value, and you have this equation to calculate the accuracy. And for the precision, you have the ability of your measurement to have the same output value every time. Next static characteristic is sensitivity. So sensitivity, what is it? Is how fast the output change with the respect to the input given, and it given by this equation you can see on the screen. The next static characteristic is reproducibility. So what is reproducibility? It's a difference between the largest and the smallest result. Now, how we differentiate between reproducibility and repeatability. So, reproducibility is the closeness of the output value when the same input applied repetitively over a short period of time with change of measurement condition, instrument observer, location, and others. Whereas the repeatability, it will have the same measurement condition, instrument observer, location, and others. Okay, next is drift. Drift is like a disturbance which is interfering input from the temperature changes, component instability, and others. Drift can be classified into two, which is zero drift and sensitivity drift. Next is the death zone. Death zone means it is occur due to the friction in the instrument, which for example, like you measure one object but you can't get the reading because the pointer is still not moving from zero. Next is the selection of instrument. When we want to buy something, for sure we have a viewpoint or a research we do, right, before we buy something. So it same goes to the instrument, where we need to have some viewpoint or selection procedure we need to follow in order to maximize the payoff ratio of the investment, which is the ratio given by the equation as you can see. The several viewpoint or value viewpoint that we can consider, first is the instrument qualities, value guided, convenience aspect, value judge, and cost inertia, and cumulative total. For the instrument quality, for sure we will take into account on the accuracy and precision characteristic, which is its sensitivity, linearity, and the zero. Next is the nature and type of data available, which is the equipment have the analog or digital or continuous output or data. Next is the further data computation, which is the instrument can do the data processing or not. Next this the dynamic response characteristic and the susceptibility to environment disturbance. Environment disturbance is like we already discussed earlier. For example, the temperature, the humidity, and others. The convenient aspect, which is the suitability for the given application, whether you want to use your instrument you want to use in the lab, for the field use, or for both, and adaptability to different size of input, which is scale expansion and the range changes. Safety in use, this is the most important. Next is the maintenance, repair, and the steady delivery, and how is the maintenance and the repair of the instrument, how's going the delivery of the equipment. Next is the material durability and non-fouling design. Cost, initial, and cumulative total. So initial cost is your installation, various attachment and accessories, which means this is the initial before when we purchase the instrument or when we choose the instrument. Then the maintenance, repair, calibration, and etc. The running cost and the expected lifetime. Alright. We know like every instrument it have a lifetime limit, and then for the running cost, whether it's using electricity or not. Now we move to the next part of this chapter, which is dynamic characteristic of instrument. The dynamic characteristic of measuring system is vary over time compared to the earlier one. Is static, it's not moving over time. The dynamic characteristic, it can be determined by applying a known and predetermined input signal to its primary element and studying the output. There are two types of dynamic input signal. First is the periodic signal with time period, which means is cyclically with time, or it repeating itself after a constant interval. We can see as on the picture here, you have the repetitive motion, right? First, and then you have the second is repeat in a constant interval. Next is transient signal. It is not changed with time. Sometimes the signal becomes zero after a certain period of time. Thirdly is random signal, which is the time is not fixed. We can see from the picture the time, the period, and the amplitude is not same, which means it's a random. Dynamic characteristic can be classified into two, which is steady state periodic and transient, which is lasting only for a short period. Most measuring system, it can be categorized into first order system or second order system. This is the calculation parts for this chapter that we will cover later. And we have three assumptions, which is the restoring element, for example, spring are linear, damping is viscous, means it's consistent, the system is a single degree of freedom system. For the first order system, the main point or the important point is zero mass. We can see on the figure 3.2, the mechanical model of the first order system. It consists of the spring, a dashboard in the parallel, and the damper, but it does not consist of mass. This is how first order system constructed. And for the second order system, it consists of a mass. This is the main, or this is the difference between first order and the second order system. Okay, we can see here in the picture 3.6, the system consists of a mass, a spring, and the damper and the platform. One of the application is the seismic device spring mass start. So the function of the seismic device is to measure a vibration in the object by using a transducer. This is the figure of seismic instrument showing forces acting on the mass.